In this video, we are going to review what you already know about the quadratic formula and add in our complex solutions. So just the first thing you want to write down is the distinction between the quadratic equation, which is the ax squared plus bx plus c equals 0, and the quadratic formula, which comes from that equation, the letters that come from that, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there's a part of this where we're going to kind of explore the different types of roots that we can get, and that's going to be what's called the discriminant. So the discriminant is the number that would come out underneath the radical, that b squared minus 4ac. So we have four scenarios that we're going to look at. B squared minus 4ac is greater than 0, meaning it's positive. If that's the case, you're going to get two real answers. And then we have two branches that come from that. If you have a perfect square number, for example, 16, if you take the square root of 16, you get 4, which is a rational number. So we will get two rational numbers, or rational solutions. If it's not a perfect square, you will get two irrational. So not only are you going to want to memorize, the quadratic formula, but you want to memorize these types of solutions that you will get and the names for them. Okay, b squared minus 4ac equals 0. You will get 1. This is the only time you get one solution, one real rational root or solution. And the reason for that, when you take the square root of 0 and you get 0, there's no plus or minus anymore. You're just going to get that negative b over 2a. Okay, and the last scenario goes with what we just learned about complex numbers. If you get less than 0 or a negative number underneath your radical, you will get two imaginary or complex roots. Complex would be if you have a real and imaginary part, and then the imaginary would be just the imaginary part. And you could get both of those scenarios. So what we're going to do in this video is actually just explore the discriminant without doing the full quadratic formula in our first couple examples. So the directions are find the discriminant, which we actually will keep doing when we do the quadratic formula, and determine number and type of roots. And we're going to use the information that we just outlined up top here to come up with that information. So our first example is 9x squared minus 24x plus 16. It's already equal to 0, so that's important when we are solving or evaluating this discriminant. I'm just putting the ax squared plus bx plus c underneath. And then we're going to be doing b squared minus 4ac. So we'll be plugging in negative 24 minus 4 times 9 times 16. Now this is something you can go right to your calculator and plug in all in one shot. And that's something, if we're doing the quadratic formula, this is the inside of the radical. You'll always want to do this without the radical part. Okay, so that gives us 0. 0 is our middle solution, so our discriminant is equal to 0. And then when we talk about the roots, it's one real rational root. And you want to write all of that information out, the real and the rational, for this. Okay, so that's our first example. Second, 7a squared minus 2a plus 5 equals negative 2. Now this is not equal to 0, so I want to make sure I get it equal to 0. I will add 2 to both sides. So I get 7a squared minus 2a plus 7 equals 0. We're going to put that into our b squared minus 4ac to find our discriminant. So negative 2 squared minus 4 times 7 times 7. And it's worth, while you're watching this video and taking notes, to also practice this in the calculator and make sure that you're getting the answer the same way, using all the same parentheses that I'm using. So this is equal to negative 192. That is your discriminant if you're identifying that. And then for roots, if we go up top, this is less than 0 or negative. So we're going to have 2 complex roots. The only time you would get just imaginary is actually if you're missing this middle term here. There will be times where we will see that come up. So I would stick with complex mostly for your answer for that. Third, x squared minus 9x plus 14. So we're going back to one that's already equal to 0. Negative 9 squared minus 4 times negative 9 times 14. Plug that in your calculator. And hold up 1 second. We're going to go back. I need to fix something real quick. It should have been 4 times 1, and I put negative 9. I just realized that should. So this should come out to be 25. And actually, if you did make a mistake like that, you could go back up and edit. So this gives me the opportunity to show you that. You can go back and grab it. I'm going to delete out the negative and overwrite with a 1. So it does come out to be 25. Apologize for the mistake. The discriminant here is 25. Now that is a perfect square. It's positive and perfect. You don't need to write this down. I'm just writing this for notes purposes because that tells you for your roots, you're going to have 2 real rational. So anytime you get a number here, it's 2. The only time that it's 1 is when you have 0, now that we've seen a few examples. And I just want to look at one more example, and this is the scenario we haven't seen yet. So 5x squared equals 8x plus 2. I'm going to subtract the 8x and subtract the 2. So I get 5x squared minus 8x minus 2 equals 0. We'll plug in the discriminant and make sure I put everything in correctly. So we're good. B squared minus 4ac. And if you plug this in the calculator, I'm going to skip that part since we did this 3 times already. You should get 104. So your discriminant is 104. This is also positive, but not perfect, or not a perfect square. So that means you will have 2 real, but instead of rational, it will be irrational. And if you think about it, if you put in the square root of 104 in your calculator, you get that decimal that doesn't repeat and doesn't end. But if I did square root of 25, you get the nice result of 5. So the nice result is your rational. The one that's not repeating and is a crazy decimal, that is your irrational number. Okay, so that concludes our video for the types of roots and finding the discriminant. Our next video, we'll start looking at the full quadratic formula.